Hello, we're moving on to our next topic here, which is solving quadratics by the quadratic formula. Okay, so this method is to use to find any solutions for any situations that we have, because there are going to be some cases where we can't factor and we can't solve by taking the square root. So we have this method, which solves every single possible quadratic that you can come up with. It's a very systematic way for doing it. Okay, so to start with, let's identify what the quadratic formula is. So this is for any quadratic, ax squared plus bx plus c. We're still identifying the a, the b, and the c. And this is your formula that you're going to be using. And in class, so I'll show you a fun little song to help you remember it. But it's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. One big fraction with the 2a on the bottom. And what you can see here is we got negative b over 2a, like we were doing with the vertex. That could help you remember what's on the outside of the square root. So what you'll need to do from here is just identify your a, your b, and your c, and then substitute them into the formula, and you're going to simplify it down. So why do we use the quadratic formula? The quadratic formula allows you to solve any quadratic equation. Sometimes you can factor them, but if you can't figure that out, you can do this anytime. An important piece of the quadratic formula is what's underneath the radical. So because of the radical, the square root, it has a lot of limitations to it. B squared minus 4ac, it's called the discriminant. It helps identify what types of roots we're going to have. So this is an important piece to make sure you're writing down. It's the b squared minus 4ac. Again, it's called your discriminant. So the discriminant tells us a lot about the types of roots that we're going to have. So why is it important? Because it's underneath the radical, you have to make sure the types of numbers that can be underneath there. So it could be a positive number, it could be a negative number, or it could be the value of 0. And it tells you the types of roots that you're going to have. So depending upon whether it's positive or negative or whether it's a 0, will tell you what types of roots you're going to end up with. So please fill this chart in as we go. If the value underneath the radical or the discriminant number is negative, then that's going to tell you that we have two imaginary solutions. Because you have to keep in mind that we're taking the square root of a negative number, and we don't do that. We saw that in the solving by taking the square root problem. If we had the value of 0, if we take the square root of 0, we're getting just 0. So if you look at the quadratic formula, it's negative b plus or minus the square root. So you'll end up doing negative b plus or minus 0, which has no effect. So that means we end up with one real solution. Then for the positives, we have two cases. The first case here is if we have a perfect square. That means we have two real rational roots. That also means we could factor it if we wanted to. If we have positive and it's a non-perfect square, then we have two reals and irrational. So what that means is we have a square root in our answer. We can simplify our square roots like we were doing before, but the answer will have a square root in it. Okay, so let's take a look at an example. We're going to find the value of the discriminant and describe the types, what's going to end up happening because of it. So if this is our equation here, we got 2x squared plus 7x minus 11 is equal to 0. We're going to identify a, b, and c. So a is 2, b is 7, c is negative 11. So we're doing that same stuff that we did just like when we identify with factoring. A, b, and c doesn't change. So then we're going to put it into the b squared minus 4ac. So what you see is I have 7 squared minus 4 times 2 times negative 11. And we're going to simplify this down and we get 137. So when I ask you what's the discriminant, you'll tell me the number without the radical of 137. So when we go through our list, is it a negative number? No. Is it 0? No. Is it positive? Yes. Then you ask yourself, is it a positive perfect square or a non-perfect square? If it's not a perfect square like this, then it's going to be two real irrational roots. Okay, so the answer will have a square root of 137 in the answer. Okay, if it can simplify, then do that. Okay, all right, so let's keep going with that and actually solve the quadratic. So we have 2x squared plus 7x minus 11. Again, a is 2, b is 7, c is negative 11, and we're going to substitute it into the quadratic formula. So the first thing says negative b, so I'm going to take the b value and change its sign, just like with the opposite b over 2a. Then the next piece is b squared, so we'll have 7 squared, minus 4 times a, which is 2, and then c, which is negative 11, divided by 2 times a, so 2 times 2. When we do these, we're going to simplify the discriminant and then simplify the denominator, and we go from there. So when I simplify the discriminant, I got 137. We saw that in the previous example. And then the bottom 2 times 2 is 4. Now, 137 cannot be simplified. It is a irrational number, so we're actually going to leave this as the answer of -7 plus or minus the square root of 137 all over 4. Now, if we're going to graph these, you can go ahead and type that into the calculator. When you're doing that, we can go to alpha, which is here, and then, oops, I gotta turn on. We can do alpha and then y equals, and it'll bring up a list of fractions. So to do this one, you can go ahead and hit enter, and you can type in the fraction just like you see it. Now you're going to have to do it once for plus and then once for minus. So it's going to give you your two answers that way. You can't put plus or minus into the calculator. Okay. So let's do one where it's going to work out nicely. So we got 3x squared minus 7x plus 2. Now the key thing to remember also is remember to put it in standard form. This already is. So highest exponent to lowest exponent before we identify a, b, c. So a is 3, b is -7, c is 2. So if I substitute it in, I get positive 7, because remember it's opposite b. -7 squared minus 4 times a times c, or 3 times 2. And on the bottom is 2 times a. So then I'm going to simplify the discriminant, and I get 25. Then I'm going to simplify the 2 times 2 to get 4. And I'm going to take a look at this number 25. So I see 25 here. This is a positive number, and it's a perfect square. So what that tells me is I'm going to have two rational roots. What that also tells me is I can factor the original problem, okay, to get the answers. And sometimes that might be a better root for you, okay? So if not, we can take the square root of 25 and get 5. So I have 7 plus or minus 5. Now when we go to get our actual solutions, we have to separate one with a plus and one with the minus. We can't do them at the same time. So 7 plus 5 is 12, divided by 4 is 3. 7 minus 5 is 2, divided by 4. We have a fraction, which is fine, and we get 1/2. So the solution to this, even if we were to factor, would give us 3 or positive 1/2. Okay, let's do one more. So we have 4x plus 9x squared plus 1. This is what I was saying, is we got to make sure we put it in standard form before we identify. So we get 9x squared plus 4x plus 1. Identify, we get 9, 4, and 1. Substituting it into the quadratic formula. So this is just substituting the values into the formula. -4 plus or minus 4 squared minus 4 times 9 times 1. And on the bottom is 2 times 9. So in the numerator, or in the discriminant, I get 16 minus 36, which is a -20. So at this point in algebra 1, we're going to identify that as an imaginary root, and we're going to stop. When you get to algebra 2, you'll keep going. But with algebra 1, we'll say this is imaginary, and I'm done. So and that's all because I have a square root of a negative number, and we can't do that in our calculators. Okay? All right, so these are the key steps to do. You first identify A, B, C. Then we're going to just substitute in the quadratic formula, simplify the discriminant and the denominator, and then if we can, split and solve. And that's only really if we have a perfect square. Okay? If you have any questions, please make sure you bring them back to class next block, and I will see you later.